Hello my friends, welcome back to Science Round. Now I have no time to waste right here because I have now got one of the most weighted chapter, or I should say the most weighted chapter of electrodynamics, that is the current electricity. So let's start, come on. What is I? I is dq upon dt. Yes, as we know by q equals it, so I equals dq by dt. That is current is changing current per change in time. That is the current is rate of change of flowing charges and nothing else. Now what is next? Next is electromotive force. What is electromotive force? It is the potential difference between its two terminals in open circuit. That is just the voltage applied by the battery in an open circuit. That is epsilon equals to V open. Now what is drift velocity and current density? Let's see. What is drift velocity? Drift velocity, the velocity of free electrons in a conductor when an external electric field is applied. That is, now let this be any arbitrary conductor, any conductor of any shape. When we apply an external electric field, then the free electrons move with certain velocity, and that velocity is nothing but the drift velocity. You will see the formula next time. Now no, it's here formula. Now let's read the second point. When E bar is not applied, the number of electrons moving from left to right balance the number of electrons moving from right to left. Yes, we know all the electrons flowing or balances each other, and thus the conductor becomes neutral. That's very obvious. Now if S is the cross-sectional area of that conductor, Vd is its drift velocity, and is the number of free electrons per unit volume having charge E. We know what is the value of E. 1.6 into 10 power minus 19 coulombs. Then what is I? The current is number of electrons into E, that is charge of electrons, into the drift velocity into its surface area, that is I equals to N into A into Vd into S. From this formula we can find out the what do we say, we can find out the drift velocity, that is I upon NES. When we know that J is current density, of course J is current density, then I upon S, J equals I upon S equals to NEVD. That is, then thus we can say that VD equals to J upon NE, because J is I by S, that is current per unit surface area, since it's current density. So VD equals to J upon NE. We completed this paper. Now let's get on to our next page, which tells us about what the fuck, Ohm's law. Okay, Ohm's law. What is Ohm's law? Ohm's law is nothing more than V equals IR. Yes, I wrote right. Of course you must know the formula. Ohm's law, V equals to IR, that is the potential difference is equals to the current into its resistance. That is, when the resistance is applied as 1 ohm and the current 1 amperes is passed through it, then the potential difference produced is 1 volt, nothing else. What is ohmic substances? The substances that obey the Ohm's law are nothing but the ohmic substances. Non-ohmic substances, the opposite. Of the ohmic substances, V per I, or V versus I graph, is straight line. Tan theta equals to V by I by V, I'm sorry. And that's equal to G. We'll study it later. And just now it is G. If G1 is greater than G2, then R1 is greater than R2. You can see G equals 1 upon R. Means it's inverse of resistance is the G. Now what is non-ohmic? Simple opposite. V by I graph is not a straight line. Examples, yeah, transistors, vacuum tubes. They are non-ohmic substances. You have to learn them. Now V by I equals to R equals to constant is not obeyed. Simply opposite. Then why did I write this? Come on. Now let's go to resistivity. What is resistivity? Rho equals to R times A by L. That is, resistivity is the resistance of the conductor per unit area divided by per unit length, or you must say per unit length per unit area. That is, rho equals to R upon L by A equals to R A by L, and nothing else. Rho is constant for the metals, depends on the nature of materials of alloys. Rho of alloys is more, and the resistivity increases on adding impurities. You have to learn these things. And conductivity equals to L upon Ra, that is 1 upon rho. 1 upon rho, nothing but conductivity. Temperature coefficient alpha, that is the change in resistance whenever we increase the temperature. That is, R0 is its resistance at 0 degrees Celsius, R1 is resistance at T1 degrees Celsius, R2 is resistance at T2 degrees Celsius. Then what is alpha? Alpha is temperature coefficient, which is RT minus R0 upon R0 T. where RT is the resistance at T1 degree Celsius, R0 at 0 degree Celsius upon R0 T. So that's it, and equals to R2 minus R1 upon R1 T2 minus R2 T1. That is, we can say the change in resistance or the resistance as we change the temperature, and that's all. And T is the original temperature, and alpha is positive for metals. As you can see, it's written here, alpha is positive for metals. First the slope, and if slope of T1 is greater than slope of T2, then T1 is less than T2, and G1 is greater than G2. Come on, you have to learn this. R1 alpha 1 equals to R2 alpha 2. That's quite obvious. The resistance into its temperature coefficient is equal to its another resistance into its another temperature coefficient, and nothing else. Now what our next page says is about thermistors. What are thermistors? They are heat sensitive non-ohmic devices. The main use of thermistors is they're heat sensitive. Yeah, they sense the heat and nothing else. Not much of the applications, but they have high positive or negative alpha, this temperature coefficient. Now about superconductors. Now if we talk about superconductors, then these are the things which get into just zero resistance just after falling some temperature. As it's written, that temperature is critical temperature. That is, as we just decrease the temperature after a particular point, then the resistance becomes absolute zero. That is, it just acts like a closed switch. The EMF is not applied. Steady current can be maintained in superconductors. Yeah, if we do not maintain the EMF, then the steady current can be maintained, and that's itself the actually it's the property of superconductor and nothing else. Now I hope I need not have to explain you these things, that series resistance R equals to R1 plus R2 plus Rn. But for G, it's exactly opposite. 1 upon G equals to 1 upon G1 plus 1 upon G2 plus 1 upon plus Gn. For parallel types, 1 upon Rp equals 1 upon R1 plus 1 upon R2 plus 1 upon Rn. Where it's totally opposite for G, that is Gp equals to G1 plus G2 plus what do we say, Gn. Now if resistance is in series, parallel, mixed grouping, then method of successive. Now you won't understand the method of successive reduction right now if you don't know, because after this current electricity I'm gonna solve my some problems on it, and that times we'll see some special cases. Now if R is wire with resistance, and if R is the resistance of the wire and it's cut into n equal parts, then and all of them are done in parallel, then effective resistance would be R upon n square. Theory part again. N wires of equal resistances, number of combinations can be made to give different resistances. I'm sorry. So if we cut the wire into n parts and we have to give all the combinations of the resistances, then there will be total 2 power n minus 1 resistances. And if you want to give unequal resistances, then 2 power n resistances. That's nothing. Now in our next page, what does the third point says is, if two resistances of ρ1, ρ2 and L1, L2 are connected in series, then what would be the equivalent resistivity would be ρ1, L1 plus ρ2, L2 upon L1 plus L2, our very daily formula, of course. And L1 equals to L2, then conductivity sigma equals to 2 sigma 1 sigma 2 upon sigma 1 plus sigma 2. And we know if cross-sectional area is A1 and A2, length is same and are in parallel, then equivalent resistivity equals to ρ1 ρ2 A1 plus ρ1 ρ2 A2 upon ρ1 A1 plus ρ2 A2. You have to remember this thing, but it's not quite weightful, not quite massful, because it has no weightage in exams, but just as a formula. Now if we have been given two areas and which have two charge densities, that is sigma 1 and sigma 2 respectively, then simply the total sigma on them would be their average, that is sigma equals to conductivity equals to sigma 1 plus sigma 2 by 2. I believe that our today's lecture is over. Let's wind up here, and in the next topic I would be just explaining you the electric cells and their connectivities. So I hope it's over for now. See you soon, and if you find this video useful, please like and subscribe, and if you want to change my teaching style or something, then do comment, please. I would definitely entertain you. Goodbye friends, happy sciencing, see you soon.